Hello again. Let us now review briefly the history of modern cosmology. Before we could study the universe as a whole in a scientific sense, we actually discovered and understood galaxies, which are its major constituents. At first, people didn't know what they were. They were just smudges in the sky. They're called nebulae, and famous catalog is by Charles Messier, and then William Herschel also cataloged many thousands of them, and followed by others. Now, even before that was really properly understood, philosophers tried to address the question, and they thought about island universes, or what today we would call a galaxy. They had no scientific reason to believe one way or the other, but it was an interesting speculation. Now, in 19th and 20th century, more catalogs of galaxies were produced, but there was still no understanding. For example, the very basic question was, are these nebulae galaxies like the Milky Way, or are there just some smudges within our own galaxy, the Milky Way, which is the universe as a whole? So up until 1920s, the early 1920s, this was still an unsolved question. And there was a famous great debate between two astronomers, Harold Shapley from Harvard and Heber Curtis from Lick Observatory, whether or not galaxies, or rather nebulae, I should say, are island universes just like the Milky Way, or are there just some smudges of gas inside the Milky Way? The debate was inconclusive. Shapley had a wrong answer that Milky Way is all of it. Curtis was advocating that galaxies are many, like the Milky Way, and arguments were not really based on any solid experimental data. This all changed with Edwin Hubble in 1923. Using Mount Wilson Observatory, he obtained photographs of Andromeda galaxy and found a variable star, so-called Cepheid, in Andromeda. Comparing its brightness to brightness of Cepheids in our galaxy immediately told us that Andromeda is much, much further away than anything in our galaxy. Within our galaxy, people knew about stars that are clusters that are kiloparsecs away. Andromeda turned out to be several hundred kiloparsecs away. Therefore, it was a galaxy just like the Milky Way, and then all the others, which are much fainter, presumably even further out. So all of a sudden, the picture changed from Milky Way being the entire universe to a much, much bigger universe, populated with galaxies like Milky Way and others. This is how Hubble really became famous. He did something else later on, discovering expansion of the universe. But before we get into this, theory actually made some important advances. If you want to understand universe at large from physical terms, the only interaction that actually matters is gravity, because all other forces are short range except for electromagnetic force, but charges are mixed so well, positive and negative ones, so that the net electromagnetic field is pretty much zero in any average sense. Not so with gravity. Gravity cannot be canceled or compensated, and so if you want to understand how things happen on large scales, you need a theory of gravity. This came in the form of theory of relativity, and in particular the general theory of relativity. So Einstein came up with theory that describes that, and we'll talk a little more about it a couple lectures from now. But he immediately understood that this can be actually applied to study the universe as a whole, and even taught a class about that from 1919. This was before it was actually proven that theory was correct. He assumed that it's just normal matter like stars and so on, but it's finite in spatial size, and we'll talk about how that's possible. In 1917, Einstein made first cosmological models. He believed in his theory, of course, even though it was experimentally proven only in 1919. And he had something interesting. He found out that the universe has to either collapse on itself under its own gravity or maybe expand forever, collapse under its own gravity seemed like a natural thing, and in order to balance that, he introduced a force called cosmological constant. This turned out to be a very unstable cosmological model, and it's wrong anyway. At the same time, Dutch physicist Willem de Sitter developed a similar model and obtained equations for expanding universe. Now later on, two of them came up with a different model that bears names, but that's a different story. Back to observations, discovery of the expanding universe was probably one of the greatest scientific discoveries of all times. Two people need special credit here, especially Vesto Melvin Slipher, who was an astronomer at Lowell Observatory in Arizona, who measured velocities, radial velocities of galaxies, and obtained the data that were that are later used by Hubble. That's roughly the same time that Lundmark and Carl Wirtz in Sweden and Germany obtained similar results, but their plot of velocity versus estimated distance to the galaxies didn't show anything. A little bit later, Edwin Hubble plotted distances to galaxies, which are measured a little better using relative brightness as a measure of distance, against velocities, most of which were obtained by Slipher, and found this remarkable trend that the further away a galaxy was, the faster it was going away from us. This is now known as the Hubble diagram and was an immediate evidence for an expanding universe. Here is a brief explanation of the expansion of the universe. Imagine just a piece of the volume of the universe populated with galaxies, more or less uniformly distributed. If the space expands in itself, it carries the galaxies apart. And the further apart from each other they are to begin with, the larger the distances there will be next time. So the growth in the distance between any two galaxies is proportional to the distance itself. And its time derivative is the velocity. So therefore, you get the velocities of recession from galaxies from each other is proportional to their distance, which is Hubble's law. Now, Einstein got to see this for himself. He visited Pasadena numerous times in the 1930s. Here he is on Mount Wilson with Edwin Hubble and Walter Adams, another famous astronomer, looking through an eyepiece of the 100-inch telescope. This is completely faked and posed picture because that's not what astronomers do. Allegedly, Einstein declared failure to predict expanding universe as the greatest mistake of his career. And remember, he invented cosmological constant as a means of preventing the collapse of the universe. So that wasn't really needed. He failed to predict expansion of the universe, even though that was implicitly contained in his equations. And that was probably the greatest scientific prediction anyone could make. So this is why he wasn't so happy. In the meantime, two theorists really developed modern relativistic cosmological models. Alexander Friedman in Soviet Union developed relativity-based expanding universe model, and he came up with the equation that bears his name that we will use very heavily. Then, roughly at the same time, or a few years later, Georges Lemaitre in Belgium developed similar cosmological models, and also he said, okay, if the universe is expanding now, what if we just look back? It all must have started with very dense state, which was probably very hot, and he called us the cosmic egg. And so that was essentially the first notion of the Big Bang. But it was not really taken very seriously because it was a little too much of an extrapolation, and he was a Jesuit priest, and that sounds a little suspiciously like biblical creation, so that was forgotten for a little while. Then in the 1930s, relativistic cosmology really started to flourish, and here are some of the more important contributors to it. Milne developed a model that is based on special relativity. It includes no matter, it's just the dynamics of space and time itself. And Eddington, who was the person who actually proven that general relativity is right, promoted their own models and tried to think about interfaces between quantum theory and relativistic cosmology. Robertson and Walker are two mathematicians who developed a mathematical description that's actually still being used in explaining or describing expanding universe.